Landing on Mars sounds like science fiction, but since the 1970s, NASA and other space agencies have done exactly that. The catch? Mars is one of the hardest places to land in the entire solar system. In this video, we break down how spacecraft survive the descent and touch down safely. Mars has just enough atmosphere to cause problems, but not enough to help. The air is 100 times thinner than Earth's, so parachutes alone won't slow a spacecraft enough. Temperatures drop below -100 degrees Celsius. Dust storms blind sensors, and because Mars is millions of kilometers away, engineers can't manually control the landing. Everything must be pre-programmed. It's a terrifying blend of physics, engineering, and luck. The process begins with entry. The spacecraft hits the Martian atmosphere at over 20,000 kilometers per hour. A heat shield absorbs the friction and slows it down. Then comes descent. The heat shield drops away. A supersonic parachute deploys to slow the craft even more. Finally, landing. Different missions use different methods. Airbags, like those used by Spirit and Opportunity. Retro rockets, like the Viking landers, or the sky crane system, used by Curiosity and Perseverance. Each method has strengths and limitations. Airbags are large inflatable cushions. They absorb impact during touchdown, but only work for small rovers. Retro rockets offer precision, but need extra fuel and kick up a lot of dust. Sky crane allows heavy rovers to land directly on wheels, but it's a mechanically complex system. NASA's Sky Crane is one of the most incredible engineering solutions in space history. After the parachute slows the rover, it's still 2 kilometers above the surface. A descent stage with rocket thrusters takes over, hovering like a jetpack. Then the rover is lowered on cables. Once the wheels touch down, the cables are cut, and the descent stage flies away to crash at a safe distance. This allowed the 1-ton Perseverance rover to land just 39 meters from its target in 2021. Let's look at some mission stats. Curiosity, 2012. Sky crane landing, 900 kilograms. Perseverance, 2021. Same method, but with terrain relative navigation. Phoenix, 2008. Retro rockets and radar altimeter. Landed near the Martian pole. Viking 1, 1976. First successful U.S. lander, parachute and rockets. Success rate, only around 50% of Mars landing attempts have succeeded. The rest crashed or went silent. Future Mars missions will face even bigger challenges. Human landings will need to slow crafts weighing 20 tons or more. NASA and SpaceX are testing inflatable heat shields and powerful retropropulsion. The Mars sample return mission will try to launch samples back into orbit, something never done before. Safely landing cargo and humans will demand smarter systems and stronger materials. Landing on Mars is a ballet of speed, heat, parachutes, and rockets, all executed by machines millions of kilometers from Earth. And every success brings us one step closer to putting humans on the red planet. Subscribe to How for more breakdowns of the world's most complex machines.